Hey there, how's it going? This is the first video for Unit 3, the applications of differentiation. If I had my clicker, I could click right here, and I guess I don't know how to do that. Oh my goodness. Let's try this again. If I had my clicker, I would have my clicker, and then I would click on this little link right there, and it would open up something, perhaps. I don't know if it's going to. It's just off. Oh, there it is. Hey, so this is the KUDs for this particular unit. I'm going to largen them up so we can see them. That largened them up. I don't know what that did. Didn't do much, did it? Yeah, I'll go that way. So these are the KUDs for this particular unit. Unit 3, applications of differentiation. So these are the things that you need to know, understand, and be able to do before we're done. It's a giant list. You should grab a copy of this. To be able to get to tests and sort of what the benchmarks will be about. Describe the behavior of a function based on graphs. Graph a function. Explain the mean value theorem. Find the root of a polynomial with Newton's method. Determine optimum solutions. Use differentials to approximate the value of functions. So those are the things that we ought to be able to do. These are some things that we need to know in order to make that happen. Okay? Now, and we're back to here. Grab a pen. Go. Bing. Zippy. All right, so that's that. So we're talking about the extreme value theorem. I should say the extreme value theorem. If f is a continuous function, on a closed interval from a to b, that means it has a definite end and a definite beginning, then we ought to have a minimum value and a maximum value. Reasonable? Taking edge, yes? Great. So there are several types of extrema that we can have. We can have absolute minimums and absolute maximums, but we can also have relative or local minimums, and we can have relative or local maximums. So relative and local maximums are typically the peaks and the valleys. So if I have myself a relative maximum, I would have one probably right there, and I would have a relative maximum right there. When we're talking about relative minimums, that would be a valley. So right there-ish, I would probably have a relative minimum. Right there-ish, I'd have a relative minimum as well. So peaks and valleys. So the mins are the valleys. And the maxes would be your peaks. Okay, so the absolute minimum, that's the lowest low point. So if I'm looking at this particular interval and say it's closed between here and here, my absolute would probably be right there. Okay, so that'd be my absolute minimum, the lowest low that we can possibly have. And the absolute maximum, well, that's the highest high point. And if I'm looking at this on the interval, I think that is also my absolute max. Absolute max. Okay, so the highest high point, the lowest low point. That's what we're talking about. Relative extrema, peaks and valleys, but absolute is the biggest big. All right, so as it says right there, my absolute maximums and minimums can be at the endpoints, or they can be within the interval. So if they're within the interval, they're going to be at a peak or a valley. My relative, or local, mins and maxes occur at the critical numbers of the function. Okay? Critical numbers. No, that's not really what a critical number is. A critical number are the values of a function where the derivative of the function is equal to 0, or where the function is undefined. And so if we want to find critical numbers, we need to find out where is the derivative equal to 0. And I've mentioned that this is coming. This day is coming soon, right? It's here. So find the critical numbers of this function, x squared plus 5x plus 6. Well, to do that, we find ourselves a derivative. The derivative, 2x plus 5. When is 2x plus 5 equal to 0? Well, I think it's when x equals negative 5 halves. Okay, so negative 5 halves is a critical number of this particular function. Okay, it would mean that we have some sort of a local maximum or a local minimum happening at that particular location. All right, so sometimes we want to find extrema on a closed interval. So we've got some sort of a function and we want to find out the extrema. We want to know typically we want to know the absolute max and the absolute min, the biggest big and the smallest small. So what we do is we find the critical numbers. Check. We evaluate my function at the critical numbers. Check. We evaluate the function at the endpoints, because remember, the highest high and the lowest low could be at either end of the function. And once we've done all this evaluating, we say, hey, which number is the biggest? Well, that's the absolute maximum. Which number is the not the biggest, the least, and the greatest? Because big is just, like, which is bigger. Okay, we don't want that. Bad. Okay, we're talking about the least, which is the lowest value, and the greatest. That's what we're looking for. Okay? So let us do this very process right here. We're going to find critical numbers. We're going to evaluate the function at the critical numbers. We're going to evaluate the function at the endpoints. We're going to figure out which is which. Critical numbers. Ready? Begin. Find the derivative. Find where the derivative is equal to 0. Pause and reflect if you need to. Find out what the f of -3 is. Find out what the f of -1/3 is. Find out what the f of 3 is. Okay? That sounds sort of funny saying it. So -3, so -3 squared is 9. 9 times 3 is 27. -6. -6 more brings us to 27 minus 12, which would be probably 15. If I do this one, and let's go here, I've got 3 squared, so I'm still going to get to 27. This time it's going to be plus 6 minus 6, which is going to bring me to 27. And then if I do a third, let's see, so 3 times a third squared minus 2 times a third minus 6, so 3/9 is 1/3 minus 2/3 minus 6, so -1/3 minus 6 more, so -6 1/3, which is -19/3. Let's go with that. Check on that one. So these are my options. Where's the biggest number? Right there. So my absolute max happens at 3,27. My min is this one. My min, absolute min, is happening at -1/3. What is that? No, -19/3. Okay, you always want to check. I just did a little mental check to make sure that -1/3 is in the interval, because sometimes a critical number will show up and it'll be outside the interval. So you want to just make sure that you're not evaluating numbers that aren't in between. In this case, -3 and 3. See how that works? Find the critical numbers, which is where the derivative equals 0. Evaluate at the critical numbers. Evaluate at the endpoints. Make a decision. Okay, we can do this one if you like. All right, let's, shall we? Derivative 12x squared minus 2. How do we solve that? Well, we could do quadratic formula, but there's only 2 terms, so let's just figure out where 12x squared minus 2 is equal to 0, which is going to be when 12x squared is equal to 2, or when x squared is equal to 1/6, or when x is equal to plus minus 1/6. So those are my critical numbers. So we're just going to do the f of -3, the f of -1/6, the f of 1/6, and the f of 3. And it's cubed, so I really should have my calculator out to do this. It'll make life so much easier to do it. So I think I'll grab the calculator. Well, you'll see me sort of disappear, but then I'll be right back. All right, so I put the 4x cubed minus 2x minus 5 into the calculator, and we may as well use the calculator to do the evaluations for us. We're going to do it at 3, -3, 1/3, or 1/6, and -1/6. So here's what we can do. If we go back to the home screen, you may not have seen this before. We can go to vars, go over to yvars, function, and we can pick y1 because that's where we put the equation, parentheses of -3. So we can just ask the calculator to do the calculations for us. y1 of -3 is -107. So we should scoot back over to this and type in 107. Okay, -107. And then we can go back to this screen and we can do the same thing. And here's another fancy thing. Second, where's entry? Oh, right there, second entry. And then we can just go back through and get rid of the negative sign and do it again. And so for that one we get 97. And then we can go back to this one and we can do the same doodad and get second entry, and this time put in -1/6. -4.86. Let's see if we can remember this one. Second entry, and this time we want positive. Get rid of that. Boom. All right, so negative 4.6 and negative 5.3. What did I do? 97's down here. Negative 4.6 and negative 5.3. I hope that's what they were. Just double check. 1/6 was negative 5.3. Negative 1/6 is that. Okay, back to here. Back to our story. Back to full screen. So we've evaluated. Boy, that was a lot of work, but really not. And so our absolute max appears to be right here. Absolute max. Our absolute min looks like it's at the negative 107. See how that works? So check the endpoints. It's not really that complicated. It just took a long time because I broke out the calculator. All right, so now let's do this one. Oh my gosh, we got to use the quotient rule. All right, well, we can do that. Take the derivative, f prime of x equals t high minus I d Okay, there we go. So then that's going to turn into what? 6x squared plus 12x minus 3x squared plus 5. Remember the parentheses. What they do to us, x plus 2 squared. So that turns into what? 3x squared plus 12x plus 5. And we need to find the critical numbers of that thing and then go from there, right? So what we're really going to be concerned about is when's the numerator, the top part, equal to 0. So when is 3x squared plus 12x plus 5 equal to 0? 3x squared plus 12x plus 5. Everybody remember that. Say it out loud until we get to the calculator portion of things. We're going back there. We're coming here. We're going to our quadratic formula, right? 3x squared plus 12x plus 5. Program. Only one we have. Clear. 3. Enter. 12. Enter. 5. Enter. Roots, negative 0.47, negative 3.5. Okay, so here, I forgot already. Maybe I can see it if I screw this up and scroll that up. Negative 0.47, negative 3.5. Negative 0.47, negative 3.5. And then we check the endpoints, negative 1 and 4. Is everything within the things? No. So negative 3.5 isn't in the region, so we don't even worry about that one. So we only have 3 places to check. I will let you check those out, find out what the f of negative 1 is, find out what the f of negative 0.47 is, and find out what the f of 4 is. Sorry, it's a little crowded there, but you get the idea how that works. Okay? Oh, trig. We can still take derivatives of trig functions? How fun. All right, f prime of x equals, what's the derivative of sine? Cosine. Okay, what's the derivative of cosine? Negative sine, so it's going to be plus sine. Okay, and then we want to find out when's that equal to 0. When is the cosine of x plus the sine of x equal to 0? And really the question is, when is the sine of x equal to the opposite of the cosine of x? Okay, and that's going to happen at my pi over 4s, okay, because that's when sine and cosine are equal, but it's going to be in the quadrants where they don't have the same, or one or the other is positive. So if I go back to my all students take calculus, okay, in the third quadrant, first and third quadrant, they're both going to have the same sign. They're both going to be negative here, and they're both going to be positive here. So it's pi over 4 in the second quadrant and pi over 4 in the fourth quadrant. So it's going to be something pi over 4 and something pi over 4 here. So in this quadrant, it's what? 1/4, 2/4, 3/4. So 3 pi over 4, and then 4/4, 5/4, 6/4, so 7 pi over 4. It's going to be those values. So we just evaluate. We find out the f of 0. We find out the f of 3 pi over 4. We find out the f of 7 pi over 4, and we find out the f of 2 pi. We figure out which one's big, which one's little, and we go, okay? It's not that big a deal. You still need to know how to find your derivatives, okay? All right, so what else we got? We got that, and is that about it? Oh, that's going to be the assignment. Again, there's the step-by-step thing of it, and I think that pretty much will will do it for us. Hey, thanks for watching. I hope you learned something. We'll talk to you soon. Hopefully when I edit it out, it'll all make some good sense, and might have some really cool special effects as well. Hey, thanks for watching. I already said that. Bye. Maybe I'll edit that out too.